Hi, my name is Nick.
My name is Raaed.
And my name is Michael, and together we are Team Loose Screws, and this is the Hydro Homie. For this video, we're going to briefly go through the project overview, and then we're going to give a live demonstration at hand, and then we're going to go through each of our roles in the project. This includes mechanical, electrical, software, and we're also going to talk about what we learned from the project, and then after that, we're going to conclude with potential improvements that we could have added if we had more time.
The problem statement for our project is that it's very inefficient to be actively present when filling up a cup of water. During my morning routine, I fill up a bottle of water and it takes about 2 minutes for the whole vessel to be filled. During these 2 minutes, I could be doing other things in my daily routine like brushing my teeth or feeding my dog, and at the end of it, I don't even know how much water was really filled in my cup.
To solve this problem, we have the Hydro Homie. So what the Hydro Homie does is that he dispenses water through this tube after the user inputs how many ounces of water they want. And then the Hydro Homie will actually dispense the desired amount of water while the user is doing other things. The way this works is that we have the Homie pad right here. You just gotta wake up the Homie by pressing any button on the keypad. You gotta press the start button to begin. You put in the amount of ounces. For this demonstration, I'm gonna put 12. You gotta dap the Homie up just by pressing the D button right here. And then we get this cup, and then we just place it right in this position. And now the Homie starts dispensing water. So as you can see, the way this works is that we have an ultrasonic sensor right here in the back, which is also working with this flow sensor right here. It's all controlled by the microcontroller, the Raspberry Pi controller. And yeah, and now my cup is all the way filled, and I can go on my life.
So now that you've seen the Homie in action over here, I'm going to talk about my role in terms of the mechanical, electrical, and software sides of the project over here. So my role was being able to calibrate the flow sensor here, which is operated by a Hall effect type that counts the number of pulses whenever water goes through the magnetic field within the flow sensor and out through here and disperses out. That is how it's able to tell if there's a certain amount of fluid going through it. And so in terms of the software side, I was responsible for programming on the Pico board to be able to power the flow sensor here to be able to continually read data as water is going through.
So my role in developing the Hydro Homie was developing the Homie pad as well as the Homie LCD screen and kind of developing the basis of the whole state machine structure for the project. The Homie keypad works by having 2 states within the state machine, one for input sleep, which then is prompted by state input. In state input, you're allowed to enter any amount of number without going over 2 digits, having the pound as a clear button, and putting a desired amount and pressing the D button to dap your Homie moves it into the next state where the cup should be filled. The keypad has other features such as having a max limit of 64 ounces, as well as having preset values along the letter row here for 8, 16, 32, and 64 ounces. The keypad then saves this input as a variable onto the Pico, which then communicates that value to the flow sensor.
So the way the ultrasonic sensor works is that it senses whenever I place the cup here, and whenever it gets into the correct range, then it'll start dispensing water. So as you see right here, I put the cup right in front of the ultrasonic sensor, the water starts dispensing. So the way the vector code works is that there's a min and max value range in the state machine code. Whenever I pull the cup out of range, then the water stops dispensing, and then the code resets again back to its first setting.
Before we go over what we learned about during this project, I want to first go more in depth into electronics. Now for the electronics of this project, as you can see here, everything is soldered onto this perf board.
Soldering the components onto the perf board proved to be very challenging and took several days to make sure all the components were well wired within each other. Here's a closer look of the circuit board housing all of our components. The brains of our project is the Raspberry Pi Pico shown here. The pump is controlled by a MOSFET transistor shown here that is connected to a 12-volt power rail. Because all of our other components run on 5-volt level logic, we use a bidirectional logic level shifter to convert the 3.3 logic levels to 5 volts to control our LCD screen, our ultrasonic sensor, and our flow meter. Each of the leads coming out of our perf board are connected to our components using DuPont connectors. Since you cannot run 12 volts to the Pico directly, we have a DC to DC buck converter to drop down 12 volts from the power all the way down to 5 volts to power the Pico. Now that we understand the mechanical, electrical, and software components of the project, back to the video.
So one of the many things that I've learned while working on the Hydro Homie is how to be able to work and integrate the Pico board that is attached to the Hydro Homie to many other actuators, sensors, and of the type, to be able to go ahead, send signals to the flow sensor, to be able to extrapolate data from that, in fact, to be able to make it do things like, let's say, read the flow of water, and be able to disperse the correct amount of water out of it. Another one of the major things that I've learned out of working on this project is how to be able to debug. Because working on the Hydro Homie, it came into a lot of issues, and some of them were kind of unexpected, to be honest. So being able to work with the unexpected, to be able to come up with solutions, to be able to seek outside help, to be able to seek help from colleagues and friends, is one of the things that I've learned through working on the Hydro Homie.
The key things I've learned when working on the Hydro Homie were mainly interfacing with the matrix keypad, since they work differently than just an array of buttons, working with the LCD screen, as well as interfacing with the I2C interface. And I learned the basic structure for a state machine, and with the help of Eric Wertz's code, I learned how to name different states and events and functions that relate to those events, such as interrupt service requests via a GPIO pin, a timer, or polling on the keypad.
So the lessons learned on my end was changing the code, the metric code that was provided by Eric. So in Eric's metric code, there was actually two zones. We decided that for our application, we only needed one zone, which was the on and off for the ultrasonic sensor. And also, some lessons learned while 3D designing is that when you're designing, you should also make the holes a little bit bigger than they should be, and make sure the structure actually fits on the 3D printing pad.
And to conclude, the Hydro Homie works as intended, but we each have a recommendation or improvement or a change that we would like to make if we have further time to the Hydro Homie. The improvement that I would personally like to add to the Hydro Homie is to be able to add a water solenoid valve to the end of the tube hooked up to this filter right here. So that way you're able to take the tube and be able to put it into, let's say, a water faucet or into whatever inlet of water that you have.
An improvement that I would add to this Hydro Homie would be to add a water sensor to the back of the reservoir tank to let you know when the water tank is running low. This could be used with a PCB water sensor or one of those fancy infrared water sensors. So another improvement that I would add would be to add a sensor somewhere to next to the bottom of the cup, just so we know when the cup is all the way full, so the user doesn't input an amount of ounces of water that would overflow the cup. Also, this sensor could be used to add another state in the code that would just fill up the cup of water by pressing one button, and then it would tell the user how many ounces of water has been filled up inside that cup. And that concludes our project video for the Hydro Homie. Hope you enjoyed it.